This lecture will cover the following topics: the operation and principle of double acting cylinder, the solenoid valves to be paired with the double acting cylinders, the operating principle of the 5-2-way solenoid valve, and the operating principle of proximity switches or proximity sensors. So as we all know, there are two uh, pneumatic cylinders as discussed from the previous video given to you. So the first one is the single acting cylinder or SAC. So the single acting cylinder is commonly known as spring return cylinder. So wherein the air pressure is being used to push the piston rod of the cylinder for the cylinder to extend, while the spring, the force of the spring is used to push back the piston rod to its retracted position. So uh, the operating principle of the single acting cylinder was discussed from the previous lecture. So in today's lecture, so we'll be focusing the discussion on double acting cylinders and the solenoid valves that must be paired with the double acting cylinders. So from the animation, so you have there the double acting cylinder. So in a double acting cylinder, it is the air pressure, okay, so that is being used to push the piston rod to its extended position, and for the double acting cylinder to retract, so the air pressure must be injected in the opposite direction. So the light blue color represents the air coming into the cylinder, whereas the uh, sky blue color represents the air going out into the going out from the pneumatic cylinder. So in this case, okay, so as you look at it, when air is injected into the cylinder, it pushes the uh, piston rod of the cylinder to its extended position. So if we remove the flow of air, so the piston rod will be in extended position to let the piston rod of the cylinder to retract. Okay, so retract means to go back to its original position. So the air must be injected in this direction. Okay, so that pushes the piston rod to its original position or retracted position. So if you try to think of it, the main difference between the double acting cylinder and the single acting cylinder is that the way the cylinders work in returning to its original position. The single acting cylinder uses the force of the spring. Okay, so in order for the cylinder to retract, whereas the double acting cylinder uses air pressure both in extension and returning to its um, original position. So the only advantage is, so the advantage of having the double acting cylinder as compared to the single acting cylinder is that in the double acting cylinder, one or the operator can control the speed of the extension and retraction of the piston rod. Why? Because you can control the air pressure. So if you let the air pressure to be low, then the cylinder will extend in a slow motion. And if you let the air pressure to enter the other way around, okay, so that will let the cylinder retract in slow motion also. But if you want the cylinder to retract and extend in faster motion, then the operator will have to increase the flow of air going into the cylinder. But in the single acting cylinder or suck, so the only way you can control the speed of air is only in the extension. Okay, so because uh, the retraction process of the single acting cylinder is done by means of the spring. So meaning to say the you cannot control the force acted by the spring on the um, piston rod. Okay, so that would be the difference, the advantage also of the uh, double acting cylinder as compared to the single acting cylinder. But there are cases also, okay, so there are cases wherein uh, the single acting cylinders are preferred. Okay, so there are industrial applications wherein single acting cylinders are being employed because of the simplicity in the operation process of the single acting cylinder. Okay, so now the next topic will be on the solenoid valve to be paired with the double acting cylinder. So if you try to recall in the single acting cylinder, then a three two-way valve must be employed, okay, for the motion of the single acting cylinder to be controlled. So the discussion of the three two-way valve and the single acting cylinder can be found in the previous uh, lecture or video lecture given to you. Okay, so now for the uh, double acting cylinders, so this type of cylinders must be paired with the what we so called five two-way solenoid valve. So five two-way solenoid valves are used to control the position of a double acting cylinder. So take note, for single acting cylinder, it must be 3/2-way. So sometimes it is read as 3-2-way. So for the double acting cylinder, it must be paired with 5 two-way solenoid valve. So again, the number 5 there indicates the number of ports. 2 represents the number of position that the cylinder can attain. So what are these positions? So these are the extended position and the retracted position. Okay, so now there are two types of solenoid 5 two-way, I mean, 5 two-way solenoid valve. So the first one is the single coil or spring return 5 two-way solenoid valve. And secondly, okay, so this would be the typical example, no? So actual example, no? So of the uh, single coil 5 two-way solenoid valve. So if you can imagine the 3 two-way solenoid valve, it looks like the same as with the 5 two-way, except that so there are two service ports. So if you try to look at, so there are two service ports here, and then you have there one solenoid coil. Okay, so that is why we term this one as single coil or spring return uh, 5 two-way solenoid valve. The second type of 5 two-way solenoid valve is the double coil. Okay, so double coil 5 two-way solenoid valve. So as you can see, okay, so the difference between the two types is that is the number of coils actually, So the first type is the single coil. So from the name itself, there is only one coil. Okay, so the coil from our previous discussion. So this is the part of the solenoid, so wherein we supply the voltage or electricity. Okay, so once the coil is being supplied, remember, so if the coil is being supplied, so it will activate the passage of air. So similarly, in double coil 5 two-way solenoid valve, so each coil must be activated. Okay, so uh, for the air to be allowed to flow. So the operating principles of these 5 two-way solenoid valves will be discussed in the next few slides. So we just have to take a recap for single acting cylinder. So we'll use the 3/2-way solenoid valve. Okay, so for uh, double acting cylinders, so we'll be using the 5 two-way solenoid valve. But take note, so there are two types of 5 two-way solenoid valve. So the first one is the single coil. Secondly, you have there the double coil solenoid valve. Okay, so now how do 5 two-way single solenoid valve work? Okay, so you focus your attention in this animation below the double acting cylinder. Okay, so the red color represents the air flowing into the cylinder. So you have here the coil or the solenoid coil case of the single solenoid 5 two-way valve. So when we supply, okay, so when electricity is supplied through a rated voltage in this coil, so as you can see, so it will push, okay. So when current is being supplied or electricity is being supplied, so the same principle as with the previous discussion, so the coil will generate magnetism. So this would be the plunger, okay. So this would be the plunger of the solenoid valve. So this allows the direction of the airflow. Okay, so you notice the arrow. Okay, so in this position, okay, so try to take a look at when the spring is being compressed. Okay, so when the spring is being compressed, that means the solenoid valve is being supplied with the rated voltage. Okay, so try to look at as to the direction of the air. Okay, so again, when the spring is being compressed, so that means the uh, coil of this solenoid valve is being supplied with the rated voltage. So when it is supplied, so current flows in this direction. Okay, so take note, the current enters P and then leaves B. Okay, so but when we okay, so take note, but when we cut off or when we turn off the supply, so the spring pushes the plunger of the solenoid or the 5 two-way solenoid into its original position. So the original position of the plunger, okay, so of the 5-2-way solenoid valve is this one, okay. So when you supply, it compresses the spring, the air flows from P to B, but when you cut off the supply, okay, so try to take a look. So when we cut off the supply, so the air enters P and then leaves A, okay. So uh, what happens when we supply the coil with the rated voltage? So the plunger then moves, then it allows air actually to flow from P to B. Okay, so that means that the air is injected to the cylinder in this direction, thereby the cylinder will extend. Okay, so but when the supply is cut off, okay, so try to take a look at the spring when it will be released. So air enters P and then leaves A. That means that the air is injected in this direction. So it will be injected here. Okay, so follow the cursor of the mouse. Okay, so it will be injected here, and then it will push the cylinder into uh, its original position. Okay, so how do the 5-2-way single solenoid valve work? Okay, so for the 5-2-way single solenoid valve to allow the cylinder or the double acting cylinder to extend, then therefore you need to supply. Okay, so to supply the coil of the single solenoid 5-2-way valve. Okay, so when you supply, so the direction of the air will be allowed to flow from P to B. Okay, so from 1 to 4. Okay, so take note of the numbering 1 to 4. So thereby it pushes the cylinder in extended position. But when we cut off, okay, so or when we turn off the supply, then this spring here will push back the plunger of the solenoid valve, and then once it is being pushed back, then the air direction will also be reversed. Okay, so when we say it is reversed, so that means the air will enter 1 and then it will exit to 2. So once it enters 1 and then it exits to 2, so the air will be flowing in this direction. Okay, so and then it pushes the double acting cylinder back in its retracted position. So the single solenoid 5-2-way valve is sometimes termed as spring return 5-2-way valve. So the uh, 3-2-way valve or the 3-2-way solenoid valve is still a what we call this one, a spring return valve. Okay, so you notice that when we cut off, okay, so in our previous example, when we cut off the supply, so the cylinder or the single acting cylinder retracts to its original position. So just think of it in simpler terms. You may think of it as for a single solenoid 5-2-way valve. So the only way to extend, no, so or the only way to push the double acting cylinder in extended position is to turn on or to supply the coil with its rated voltage. So to retract the cylinder, okay, to its initial position, then the coil of the single solenoid 5-2-way valve must be turned off. Okay, so again, uh, for the double acting cylinder using single solenoid 5-2-way valve, uh, for the cylinder to move forward or to extend, so you must turn on the solenoid coil, and then to retract the cylinder, then the coil of the uh, single solenoid 5-way valve must be de-energized, or meaning to say it must be disconnected from the source. Okay, so the next type of 5-way solenoid valve is the double coil. Okay, so before we go through the double coil, so for the single solenoid, so basically the operation of the solenoid is the movement of the plunger. Okay, so the movement of the plunger actually dictates the direction of the airflow. So coming from the compressor going to the pneumatic cylinders. So sometimes the solenoid valves are termed as directional valve. So they dictate the direction of the pneumatic cylinders. Okay, so now single solenoid means that the way of the plunger to move back to its initial position is by means of spring. Okay, so this one. So once the source is deactivated, so this spring is uh, or the spring will push the plunger of the solenoid valve so that it will be placed in its original position. So the next type is the double solenoid 5-way valve. So this double solenoid 5-way valve uh, is being used again to control the double acting cylinder. However, the main difference between the single solenoid and the double solenoid is the number of coils. Okay, so for single solenoid you only have one coil. For double solenoid, so you have there two coils present. Okay, so coil 1 and coil 2, and then as you notice, there is no presence of spring in the uh, solenoid valve. Okay, so meaning to say this is not a spring return solenoid valve. So remember, in the previous presentation for the single solenoid 5-way valve, so the only way to move the plunger, okay, so is to supply the coil, and then the only way to return the plunger to its original position is to let the spring push it back. But in the double coil, okay, so or double solenoid 5-way valve, so we do not have the presence of the spring. So that means that you need to supply the first coil for the plunger to move, and for the plunger to return to its original position, you need to supply the other coil. Okay, so meaning to say, in the case of the double solenoid 5-way valve, the movement of the plunger, okay, so is dictated by the uh, activation of the solenoid coil. So you energize the first coil, so it will allow the passage of air. It's like this one, and it pushes the cylinder in extended position. So the only way for the cylinder to move back or to retract to its original position is to supply the other coil, this one. Okay, so once you supply this one, it will push the plunger back to its original position, so thereby allowing the air to flow in the reverse direction. Okay, so now let's have to try a recap. Let's try to have a recap of the two solenoid or the two types of 5-way solenoid valve. Okay, so for the single solenoid, again, so for if you want the cylinder to extend, you simply turn on or energize the coil of the solenoid valve. Okay, so once you energize this one, then the double acting cylinder will extend. But if you turn off the solenoid coil, then the cylinder will retract. Okay, so now for the double solenoid, so to extend the double acting cylinder using double coil, a 5-way solenoid valve, so first is you need to turn on the first coil, so the cylinder will extend. So even if you turn this one off, take note, no? So if you turn off or de-energize this coil here, this one, the cylinder, the double acting cylinder will not retract. Okay, so because the plunger, okay, so this plunger does not return to its original position, so thereby the flow of air will still be in this direction, no? The red one. Okay, so to retract the double acting cylinder, you need to turn off this one, this coil here. At the same time, you need to turn on the second coil. Okay, so in the single solenoid, so you just simply turn off the coil, and then it is the spring that will push the plunger back to its original position. For double solenoid, so you just need to turn on the other coil, but take note, the other coil, okay, so the first coil must be turned off. You cannot turn on the two coils at the same time. Okay, so why? Because the first coil is used to extend the cylinder. The second coil is used to retract the cylinder. So if you turn this one on at the same time, then nothing will happen to the double acting cylinder. So for double coil, so it must be one coil at a time. So if you want to extend, so you just turn this one on and see to it that the other is off. So to retract, you just turn this one on and see to it that the other coil is off. So that would be the pairing of the double acting cylinders. So depending on the applications or application, so one must choose either use double solenoid or single solenoid 5-way valve. So next topic would be okay. So before we continue to the next topic, so let's try to take a look at the configuration of the 5-way solenoid valve. So 5 again represents the number of ports. So 2 represents the two position that the 5-way valve can offer. So it's either extended or retracted position. So this would be the schematic diagram of the 5-way solenoid valve. So the first one is single coil, and then the second one is double coil. Okay, so now for the single coil, so you have there the solenoid coil. So one solenoid coil. For double solenoid, well, of course there are two solenoids. So you supply this one. Okay, so this one here, then the cylinder will extend. You cut off the supply or you turn off the supply, then the cylinder will retract. So in this case, you turn on this coil, the cylinder will extend, and then you turn on this second coil, and then the cylinder will retract. Okay, so now the fourth one, so the Numbered 1 represents the inlet port. So this is the port in the solenoid valves wherein you inject the air pressure coming from the compressor, and then ports 3 and 5 represents the exhaust port. Okay, so this would be the port wherein the air coming from the other side of the double acting cylinder will be exhausted. Okay, so ports ports 4 and 2. Okay, so are the service port. So this is where the double acting cylinder will be connected. Okay, so port 4, okay, so uh, is the exit point of air coming from the solenoid valve to push the double acting cylinder in to its extended position. Port 2, okay, so port 2 is the exit point of the 5-way solenoid valve for the double acting cylinder to return to its extended position, I mean retracted position. Okay, so as you can see, there are 5 ports. So one inlet, 2 service port, and 2 exhaust port. For 3 two-way valve, if you remember, 3 represents number of ports, one inlet, one service, and one exhaust. Okay, so now the next topic would be uh, the proximity sensors. Okay, so how important are the proximity sensors? So the sensors, uh, the proximity sensors are being employed in an electropneumatic system, and they detect the position of the cylinder, either it is in extended or it is in retracted position. Okay, so take note, uh, one cannot know that the cylinder is in extended or in retracted position, particularly if the cylinder cannot be seen by the direct visual observation, okay, so or direct uh, visual point, no, so wherein the naked eye or the eye of the operator cannot see directly the position of the cylinders, whether it is single acting or double acting. So we'll be using 2 types of proximity sensors. So the first one is the reed switch. So reed. So the reed switch is an electrical switch, no? So the application of reed switch is done through the use of magnetism. So the second type of proximity sensor is the limit switch. So limit switches uh, may change contact uh, only if they can detect mechanical presence, no, of the pneumatic cylinders. So reed switches uh, implies the use of magnetism. Okay, so meaning to say the detection of the position of the cylinder when using reed switches is done by means of magnetism. For limit switches, the detection of the position of pneumatic cylinders is being detected by means of mechanical means. So the mechanical means stated is the uh, bumping. No? So the bumping of the piston rod to the switch, or basically there must be mechanical contact, no? So mechanical contact between the piston rod and the switch itself. Okay, so just like the switch in our home, when we press, so there is a mechanical contact. The light will either turn on or off. So in the case of limit switch, so the switch must be or must have a contact between the pneumatic cylinder and the switch itself. But for the reed switch, so there is no physical contact or mechanical contact, but there must be the presence of magnet within the piston rod of a pneumatic cylinder. So one by one, we'll discuss thoroughly how the limit switches and reed switches must be installed in a pneumatic circuit. So the first one is the limit switch. Okay, so this is an example of a limit switch. So with a lever and a roller. So if you try to press this one, okay, so you try to create a mechanical contact with the lever. So the contact here, okay, so if you try to look at from common, okay, so try to follow the cursor. So actually it is close, going to NC or normally close, right? So however, if you try to look at from common to open, so it does not have any contact between these 2 points, okay? So once you press the lever or the roller, okay, so you create a mechanical contact, so somehow this will be pushed down, okay, so thereby pushing this strip here, this one, so this strip here will be transferred to NO point. Okay, so thereby from open it becomes closed, or from common to NC, from closed, once you hit or once a mechanical contact happens, uh, then this strip here will transfer to NO, thereby from closed it becomes open. So how do we position the limit switches in a pneumatic system? So as you can see, I have here a double acting cylinder. So the double acting cylinder can either extend or retract. Okay, so that would be the movement of the double acting cylinder. So you have their limit switch. Okay, so that is installed here. So with its lever, okay, so uh, situated here, and then we have also the second limit switch. Okay, so located in this position. So when the cylinder extends, so it creates a contact with the switch. So then it can detect that the cylinder is in extended position. Okay, so when it retracts, no, so when the cylinder retracts, so it leaves this limit switch here. So by the way, limit switches are spring return switches. So they are just like push buttons. When you press, so it changes contact, but when you release, so it goes back to its original contact. Okay, so going back to the setup, so once the cylinder retracts to its original position, so it creates a mechanical contact between the ruler or the lever of the limit switch situated here. So thereby, it can detect that the cylinder is in retracted position. Okay, so that's how the limit switch works. For the reed switches, so this would be the uh, available reed switch. one of the available reed switch in the market. So reed switch are installed in. Okay, so unlike the um, limit switch that uh, it needs to create mechanical contact, reed switches are situated or positioned or attached in the body of the pneumatic cylinders. So the limit switches are attached to the end, no? So outside part of the cylinder wherein you have to make sure it must be hit by the piston rod once it extends or it retracts. So the reed switches are installed in the body of the cylinder itself. Okay, so this would be a reed switch for extended position, and then this would be the reed switch for the retracted position. Now let's try to have the idea on how the reed switch works. Okay, so before we continue, so this would be the positioning of the um, proximity sensors. Okay, so for the limit switch, so it must be installed outside the pneumatic cylinder. Okay, so wherein you have to see to it that the limit switch can be hit. So when the cylinder extends, so it will create a mechanical contact with limit switch 1, and when it is in retracted position, then it will be or it will create a mechanical contact with LS1. So for the proximity sensor or the reed switch, so it must be installed in the body. So wherein uh, the base of the piston rod, okay, so must be of magnetic material. So for limit switch, the base of the piston rod is 1. Okay, so it's not or may not be of magnetic material. Okay, so for the reed switch, the base of the piston rod, okay, so this one must be of magnetic material because it will be detected by the reed switch. So once the cylinder extends, so this base here will be located here. Okay, so then it must be detected by the reed switch 2 or RS2 sensor. Okay, so depending on the application, so one have to choose either to use reed switch or to use limit switches. Okay, so now if the application requires physical contact between the rod and the sensor, then uh, limit switch must be used. But if no physical contact is accessible or the physical contact cannot be installed, then you have to make use of the reed switch. So how do reed switch work? Okay, so if you try to look at, so this would be the base of the piston rod. Okay, so this one. So the black one is made of magnetic material. Okay, so you have to take note when you install reed switches, then you have to see to it that the cylinder must be of magnetic type. That means it has a magnet attached in the base of the piston rod. Okay, so now if you try to look at this point, so the reed switch is actually open. Okay, so but when the base of the piston rod is under the reed switch, so since it has a magnet, the black one, so it will pull Okay, so it will pull this contact, thereby it creates close contact uh, in the switch. To better understand the topic, let's go to the simulation software, and then we'll try to have an example for the double acting cylinders together with the 5-way solenoid valves. So assuming that assuming that you have already downloaded the software, so you can go to the downloaded software. Okay, so okay, assuming that you have already extracted the fluid sim software, again, so to run, you open the folder, go to bin, and double click the application icon. Okay, and then you'll be directed to this new window. Okay, so again, these are the component libraries that may be of use for electropneumatic simulation. So again, not all of these components will be used. Okay, so we'll just pick some that may be useful, particularly in the simulation of our laboratory exercises. Okay, so to begin with, okay, so we can click this icon. Okay, so to create a new working environment or working area. Okay, so you'll be prompted with or you'll be given with this another new tab. Okay, so this will be the okay, so let's close the other one. Okay, so you'll be given with this new tab. Okay, so this will be the working area. Okay, so now to illustrate again the principle of a double acting cylinder. Okay, so we first pick. Okay, so we pick in the actuator side. Okay, so you choose, click double acting cylinder, and then drag it to the working area. Okay, so then first we need to find the appropriate uh, solenoid valve for the double acting cylinder. So we have here 5-way solenoid valve. So this is for the single solenoid or single coil. Okay, so and then the compressor. Okay, so which can be found in the supply elements. So click and then drag. Okay, so okay, and then this would be uh, the compressor will be connected to the uh, inlet port, so which is port number 1. So the service ports will be connected to the double acting cylinders. So okay, so just click uh, 2 to this point and 4 to this point. Okay, so this is now the pneumatic circuit using the double acting cylinder. So Okay, so by the way, we can add, okay, so we can add um, okay, so we can add in the shut off valves and flow control valves. So we can add the throttle valve. So this is used to adjust the uh, airflow. Okay, so this can be used to adjust the flow rate of the air coming from the compressor going to the um, pneumatic cylinder. So again, click, and then you click this one, and then okay, so you can rotate it by 90 degrees. Okay, so you can insert it in between the valve and the uh, cylinder. So you click this line, and then you can delete, and then perhaps you can insert. Okay, so click and then insert, and then you can copy. So just uh, press Ctrl C, then Ctrl V, and then you will have the flow control valve. Okay, so okay, so again, the purpose of the flow control valve is to adjust the flow rate of the incoming air from the solenoid valve going to the cylinder. So to adjust width, so you can double click. Okay, so or you can just put your, okay, so double click, and then you can adjust the opening. So in terms of percentage, okay, so like you can have 50% or 10%, for example, or 20%. Okay, so 100% means that the opening of the valve is fully open. So you can imagine the throttle valve as similar with a faucet. So in a faucet, when you open the knob, so the outgoing flow of water will be uh, very high. So you can adjust the opening of the faucet by turning the knob. Okay, so similarly in the throttle valve, you can adjust the opening, so wherein you can regulate the flow of air. So as mentioned in our uh, in the lecture from the previous slides, so the main advantage of the double acting cylinder as compared to the single acting cylinder is that in a single acting cylinder you can only adjust one speed of the cylinder, because you cannot adjust the speed the other way because it is mandated by the spring. So in the double acting cylinder, so you can adjust the airflow, so to which you can increase or decrease the um, extension and retraction speed of the double acting cylinder. Okay, so to illustrate with, okay, so let's build again the pneumatic circuit for the single acting cylinder. Okay, so for the single acting cylinder, so you click this one. Okay, so then we'll try to compare. Okay, so then you have there the flow control valve. Okay, so you go to the flow control valves, or you can copy this one. Okay, so you double click, you can click check display opening level. Okay, so let's have it 20% for example. Okay, so you may also hide the opening level. Okay, so connect it to the cylinder, and then we need to find the, okay, so the solenoid valve intended for single acting cylinder. So you can click this one, three two-way. Okay, so okay, not this one but the other one. Okay, I think this would be, okay, so the three two-way valve. So again, let's try to examine the difference between the double acting cylinder and single acting cylinder. Okay, so you can click. Okay, so you can have a common compressor, okay, for the two cylinders. Okay, so let's denote. Okay, so to name, okay, so to name the solenoid coil, so you can double click this part. Okay, so this one, can name it Y1 for the three two-way valve, and then we can make, or we can name it Y2 for the five two-way solenoid valve. Okay, so now remember, let's try to simulate first the double acting cylinder. Okay, so remember that for the double acting cylinder to extend, okay, so the solenoid coil of the five two-way solenoid valve must be energized, no? So meaning to say Y2 must be supplied with the rated voltage. Okay, so now in our previous example, we're using the NEMA format. Okay, so in this example, we can use the other type of ladder circuit, which is the IEC. Okay, so for IEC, you can start with the 24 volts. Okay, so positive, can place it there, and then the negative or zero. Okay, so you can place it here. Okay, so to take note, for cylinder, double acting cylinder to extend, Y2 must be energized with the rated voltage. Okay, so when you say energized, so this must be supplied with the rated voltage, so which is 24 volts DC. So when you say energized, okay, so the word energized means that you give the rated voltage. So again, from your electrical circuit subject, when you say voltage, so you must have the two terminals connected to the source, no? So for example, one terminal must be connected to the positive, one terminal must be connected to the negative. So for the coil, so the coil must be connected to the positive terminal, and then the other end must also be connected to the negative terminal. So okay, so to click, okay, so to use the IEC format, you need to go to the valve, okay, or the solenoid coil. So click valve solenoid, this one, and then uh, put it here. Okay, so then perhaps you can double click and then label it Y2. Okay, so this means that uh, this is the coil for this 5 two-way solenoid valve. Okay, so again, in order for the double acting cylinder to extend, so this coil, or the coil of 5 two-way single, or the coil of the single solenoid uh, 5 two-way valve, or basically Y2, must be energized. So when you say again energized, so it must be connected to the positive and to negative. Okay, so But again, if we connect it directly, okay, so for example, if we connect it directly to the positive, just like that, so when we simulate, okay, so the double acting cylinder directly extend, okay, so its position. So to avoid that, we must insert something so that will be commanded by the operator, which is actually the switch. Okay, so we insert the normally open push button such that when the operator press the push button, the coil Y2 will be connected to the power supply. Okay, so we delete this one, click. Okay, so to choose, okay, the push button, so you can uh, click the manually operated switches, this one. So push button make, okay, so and then you drag it to the working area. So this must be connected in series with the solenoid Y2. So again, you connect it there and then it will be connected to point 2. So when we press the push button, this one, so this will create a contact, so thereby connecting this terminal to the positive terminal or positive terminal of the 24-volt supply. So we try to simulate, okay, so we click push button, okay, so long as, again, so long as the solenoid Y2 is connected to the source, then the cylinder will always extend. Okay, so if we release the push button, for example this one, release this one, so you notice that the cylinder, okay, or the coil Y2 is now de-energized, or it is now turned off, then the cylinder retracts, okay, to its initial position. So if we try to look at the difference between the operation of double acting cylinder and the single acting cylinder, so perhaps we can label this one Y1, okay, for example. So meaning to say, we will be energizing next the three two-way solenoid coil. So if we try to, okay, so if we try to turn on Y1, so the single acting cylinder extends. Okay, so if we try to release the push button, so the uh, single acting cylinder retracts. Okay, so it extends, and when you turn it off, it retracts. So in the same way, okay, so we stop the simulation first. Okay, so if we label this one Y2, okay, so Y2, so meaning to say will be energizing the Y2 coil of the 5 two-way solenoid. We can energize, okay, on and off, on and off. And then if we try to label this one Y1 again, okay, so this is for you to have a better understanding on how do the 3 two-way valve and 5 two-way single solenoid valve have a similarity in the operation. Okay, try to click. Okay, so then on, off, on, and off. So you notice that the two setup, the double acting cylinder and the together with the single solenoid 5 two-way valve will have the same output as with the single acting cylinder that uses 3 two-way valve. So the difference between the two is that the double acting cylinder can be, or the speed of the double acting cylinder uh, can be adjusted in both extended and retracted direction. So meaning to say, you can adjust the speed, okay, so of the double acting cylinder. Double click, so for example you can change this one to uh, a more slower, okay, so speed, okay, 5, and then this one can be adjusted to 5 also, okay, so and then let's make it y2, simulate again, okay, so you notice that speed, okay, so of the cylinder changes, okay, so however in the single acting cylinder you can only adjust the speed in one direction, okay, so assuming that we change this one to 5%, okay, so and then we label this one y1, okay, so uh, once we energize, so you notice the speed of the single acting cylinder in the extended direction hasn't changed, but you can change the speed in uh, retraction, no, of the cylinder. So the objective of this simulation is to present to you the similarity between the double acting cylinder using the 5 two-way single solenoid valve and a single acting cylinder which uses 3 two-way solenoid valve. Okay, so meaning to say if you have their uh, single acting cylinder together with 3 two-way valve, so you can replace the whole pneumatic circuit with a double acting cylinder using a 5 two-way single solenoid valve. So with the same control circuit, you can have the same output. So again, the advantage is that you can adjust the speed in both extended and retracted direction using the double acting cylinder. So however, in both pneumatic setup, so it is a must that the control circuit must have the what we so called latching contact, uh, since when you release the push button, even if the cylinders does not reach the fully extended position, then it will return to its uh, initial position if the push button is being released. Okay, so we can okay, so we can delete this one. Okay, so we'll focus the discussion to the double acting cylinder. Okay, so now this would be y2. Okay, so again, if we try to simulate, if you click, okay, so you click and then release, no? So for example, you click and you suddenly release. So the push button, I mean the cylinder, so automatically retracts even if it hasn't uh, reached the fully extended position. So to aid, okay, so in order for the cylinder to reach the fully extended position, even if the push button is pressed, then uh, we need to have the latching contact, okay, so which is actually provided by the relay. So take note, the solenoid coil does not offer or cannot offer auxiliary contacts. So in order for uh, you to have the auxiliary contacts, so you need to have the relay. So to click or to provide a relay, So we go to the relays. So this would be the relay coils in IEC format. Okay, so the direction of the ladder in the IEC format is from left to right, whereas in the NEMA, it's from top to bottom. So last time we are using the NEMA format, so this time we'll be using the IEC format. Okay, so the relay coil, so this would be the coil of the relay. So every coils must be connected in parallel. Okay, so this must be connected here. Okay, and then it must be connected here also. Okay, so meaning to say that when Y2 is energized, the coil of the relay will also be energized. So meaning to say, if you have their open or close contact, it will change position from open to close, or close to open. So we double click this one and then we label this one as K1. Okay, so the contacts of the relay so can be found in the general switches. So we click, and then also the brake switch. Okay, so again, for you to be reminded of the operation of a relay. So if you try to simulate, so kindly focus your attention to the, okay, so before this one, so we can label this one as K1, and we can label this one as K2 also. So this serves as the relay contacts. So the format or the symbol using IEC format will remain the same. Okay, so for the relay, K1, sorry, this is K1. Okay, so you notice that we have open and close. Okay, so when you simulate, so when you energize K1, so this becomes closed and this becomes open. So try to focus your attention in these contacts. So when we simulate or when we energize Y2, so since K1 is connected in parallel to Y2, so these contacts must uh, change position. Okay, so you can start by click. So you notice that the open becomes closed and then the close becomes open. So to start with, okay, so to have the latching contact, so we can make use of the, okay, so we can make use of the normally open auxiliary contact of a relay. Okay, so to be connected in parallel with, okay, so the uh, push button. Okay, so and then we can simulate. So okay, even if we release the push button, so the cylinder continues to extend to its fully extended position. It is because the uh, solenoid coil Y2 is always energized because of the help coming from the latching contact. Okay, so without the latching contact, then uh, once we release the push button, so the cylinder will automatically retract. Okay, so unless otherwise you hold the push button, so until the cylinder is in fully extended position, then the cylinder will continue to uh, extend. Okay, so now to stop this operation, okay, so what I mean by stop is we want to retract the cylinder to its initial position. So that can be done only by turning off the solenoid coil. So the same as with the single acting cylinder from the previous discussion. So we can turn off Y2 by cutting the supply. Okay, so when I say cutting the supply, so one terminal of the supply must be cut off from the circuit, and then that can be provided by a normally closed push button. Okay, so when I say uh, normally closed, so we can, okay, so we can click this one, push button brake. Okay, so we try to adjust this one. So by the way, this again, the IEC format, so of the ladder circuit. So in the IEC format, okay, so in the IEC format, so the ladder circuit is made in the direction from left to right. So this will be the first rung, second rung, and then when you add another operation, it will be connected here going to the right. Okay, so this will be connected. So again, normally closed push button must be connected in series. Okay, so remember in your electrical circuit subject, series connection means common current connection. So when one of the elements in the series circuit is disrupted, that means it is cut off, then everything in the entire circuit will be de-energized. So that is the reason why we connect the normally closed push button in series with the entire circuitry, okay, this one. So in such a way that if we press this one, when this becomes open, so everything in the circuit will be de-energized or will be turned off. Okay, so by the way, you can label this one. Okay, so you can label it stop, and then for the other one, okay, so by the way, you can adjust. Okay, so and we can label this one as start. Okay, so and then we try to simulate again. Okay, so you can click start, and then the cylinder retracts, I mean extends. For the cylinder to retract, then okay, so the only way is to de-energize Y2. So when you say de-energized Y2, so that means we need to turn off the supply for Y2. So that can be done by pressing the stop push button. So if we try to press, then Y2 is de-energized, and then the cylinder now is in its original position, which is the retracted position. Okay, so that's how we extend and retract a double acting cylinder using a single solenoid 5-way valve. So now let's move to the double solenoid. Okay, so we stop the simulation. Again, you can build the equivalent circuit. Okay, so uh, of the control circuit using the IEC or the NEMA format. Okay, so for NEMA, everything can be found under the ladder symbols, this one. Okay, so whereas for IEC, so okay, so you have a lot of tabs to be used, the relay, the switches, the general switches, so and so on. Okay, so in the design process, so it's up to you whether you use NEMA or the IEC format. So the good thing is that once you understood the IEC and NEMA format, then you will be more flexible when you go outside CIT, like when you will be working in any industries, because there are industries that follows IEC format, and then there are also industries that follows NEMA. Okay, so we try to delete this one. Okay, so and then we try to make use of the double solenoid. So we delete this one. Okay, so for double solenoid, okay, so we use the, okay, so under solenoid operated, so click 5 two-way solenoid impulse valve, this one. Okay, so click and then drag. So this time you notice that there are two uh, solenoids, solenoid coil present. So you have there this one and this one. Okay, so you can double click. We can name this one Y1 and then we can name the other one as Y2. Okay, so the same thing, the service ports will be connected to 4 will be connected to this port of the double acting cylinder. 2 will be connected to this port also of the double acting cylinder, and the compressor will be connected to okay, the compressor will be connected to the inlet port. Okay, so of the double acting, I mean of the 5 two-way solenoid valve. Okay, so you have the Y1 and Y2. So let's now have the control circuit for the double acting cylinder using 5 two-way, I mean double solenoid 5 two-way valve. So from the discussion, so we found out that for the cylinder to extend, okay, so for the double acting cylinder to extend, then the coil of this double acting cylinder must be energized. Okay, so let's try to create, okay, so the control circuit for the double acting cylinder using double solenoid 5 two-way valve. So this time again we'll use the, okay, so we can use the NEMA format. Okay, so you have there for NEMA in the ladder symbols. Okay, so you click positive first. Okay, so this would be positive, and then the negative. Okay, so again for the cylinder to extend, so Y1 must be energized. When you say energized, so Y1 must be connected to the source. Okay, so the solenoid valve symbol using NEMA, okay, so can be found here, and then you can drag it. Okay, so and then you double click, then you can rename it Y1. Okay, so the same thing, we need a push button. Okay, so for the operator, for example, to control when and okay, so to control when to energize the coil Y1. So we can click start. Okay, so or basically, so we can use extend EXT. Okay, so that means this push button is for the cylinder to extend. Okay, click it. Okay, so it must be connected in series again. So it creates contact. Okay, so when you say normally open, so or it means make contact. That means once it is activated, it will create a connection. Okay. Now, try to observe what happens to the double acting cylinder when paired with a 5 two-way or when paired with a double coil or double solenoid 5 two-way valve. Okay, so now if we try to simulate, okay, so you can click this one or press F9. So we press EXT, for example, EXT. Okay, so but if we release EXT, okay, so you notice that when you release the push button, the double acting cylinder does not retract to its original position. Unlike with a double acting cylinder, okay, so which uses a single solenoid 5-way valve. Okay, so this is the main difference of the two valves. So when using single solenoid, so in order for the double acting cylinder to remain in its extended position, then there must be the presence of the latching contact. Okay, so in order to remain the solenoid coil to be activated, uh, even if the push button is being released. For the double solenoid, even if we turn off the solenoid Y1, for example, the cylinder remains in extended position. So the only way for the cylinder to uh, retract or to go back to its original position, you must need to energize this solenoid or the other solenoid, which is Y2. Okay, so meaning to say, if Y2 is being activated, then that would be the time that uh, the double acting cylinder will retract to its initial position. So that means when we use the double coil 5-way valve, there must be two solenoids in one circuit. Okay, so and every solenoids, every coil must be connected in parallel. Okay, so the same setup with the same circuit. Uh, how do we construct the first circuit? So that would be the same way on how do we construct or how we construct the uh, next circuit for the retraction of the cylinder. So again, everything must be connected in parallel. So the solenoid coil Y2, okay, so double click again, no? Double click and then type Y2. So must be connected in parallel. Okay, so to the existing circuit. Okay, and then another push button. Okay, so must be connected in series with the coil. Okay, so Y2. So this should be retract. Okay, so we can okay, so we can type retract. Okay, so and then this one would be extend. Okay, so we can use the full word extend and retract. Okay, so and then the push button in the same way as with the first circuit must be connected in series with the coil, and everything will be connected to the source. Okay, so just like this one. Okay, so we try to simulate. So we can extend the cylinder. So the only way to retract is to press the other push button. Okay, so which actually energizes Y2. So when you say energize, it connect Y2 to the positive and negative. Okay, so when we press this one, so this terminal will be connected to the positive, and of course this terminal is already connected to the negative, so you can have retract. Okay, so extend and then retract. Okay, so extend, retract. So uh, if you try to spot the difference between the solenoid valves, 5-way solenoid valves, so the key difference is that in single solenoid, so for the cylinder to extend, the solenoid must be turned on, and then the cylinder will extend. Okay, so to retract the cylinder, the coil of a single solenoid valve must be deactivated or de-energized, and then automatically the double acting cylinder will retract. However, in the case of the 5 two-way double solenoid valve, so to extend the cylinder, so we energized or we turn on the solenoid coil, and then to retract the cylinder, okay, so it is a must that we energize the other coil. Okay, so for double coil 5 two-way valve, one coil must be or is used to extend, and then the other coil is used to retract the cylinder. Okay, so that's the difference. So take note that you cannot energize or you cannot turn on the two coils Y1 and Y2 at the same time. So for example, if you suddenly, for example, you delete, so you connect Y1 and Y2 here, so they are connected in parallel. That means if we press the extend button, so both of them will be energized. No? So try to take a look. Okay, so if we try to energize both of them, so nothing will happen. So again, Y1 will let the cylinder extend, and Y2 will let the cylinder retract. So it's the same as uh, saying a person to look to the right side at the same time to look at the left side. So no one can do that. So in the same way, the cylinder, double acting cylinder, is being commanded to extend at the same time being commanded to retract. So meaning to say, the cylinder will not be able to move. Okay, so we try to, okay, so eliminate this one. Okay, so the next example, the next simulation will be for the application of proximity switches. Okay, so okay, try to delete this one. So again, we're using a while ago the NEMA configuration, which follows top to bottom ladder circuit. So in your activity, you can choose whether to use NEMA or IEC format. Okay, so okay. So next example is uh, the application on proximity uh, sensors, meaning to say the um, limit switch and the read switch. Okay, so we'll try to delete this one first, and then we'll try to build. Okay, so okay, so we'll try to use the double acting cylinder. Okay, so in this example case, and then we'll be using the IEC. Okay, so format. Okay, so okay, so to add the sensor, okay, so to add a sensor to the existing pneumatic circuit, so we use under the actuators tab, so we use the distance rule. Okay, so this one, so just click. Okay, so if you want the sensor to be or to function as a limit switch, so you click or you put the ruler at this position. Okay, so but if you want to use the sensor as a reed switch, then it must be located in the body of the cylinder like this one. Okay, so this is for reed switch, and then this should be for limit switch, no? So take note, the function of a limit switch is to create. Okay, so the operating principle of a limit switch is to create uh, contact with the piston rod, whereas for the reed switch, so it is mandated with the magnetism principle. So that is why we put it in the body of the cylinder, just like this one. Okay, so reed switch, and then this would be for limit switch. Okay, so again, you use the distance rule. Okay, so now, okay, to start with the sensor, we need to first find the parameters of the uh, cylinder. Okay, so we can double click the cylinder and then go to parameters. Okay, so meaning to say, okay, so we'll try to look at the maximum distance that the cylinder can extend. So by default, so your cylinder can extend up to 100 mm. Okay, so basically 10 cm. So this would be the maximum distance that the cylinder can extend. Okay, so 100 mm. You can alter this one. Okay, so as given, you can alter this one from 1 to 5,000 mm. So we'll just leave it as 100 mm. Okay, so what do we mean by maximum distance is the length of the piston rod. Okay, so for example, this one. Okay, okay, so double click. Okay, 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 so we just, okay, let us troubleshoot first. Okay, so we can delete this one. Okay, so we can, okay, so again, double acting cylinder. Okay, so double acting, and then the distance rule. Okay, so I'll be using the limit switch. Okay, so again, so we try to look at the parameters. So the maximum stroke. Okay, so refers to the maximum distance that the cylinder can extend. So again, by default, that's 100 mm or 10 cm. So let's leave it as is. Okay, so for the distance rule, okay, so you double click this one. Okay, so we label uh, the sensor or the limit switch, okay, for the retracted position as S1, and then we label the limit switch for the extended position as S2. So to do that, so we can double click the ruler. So type S1, so begin with 0 and then end with 5. So this means that the width of the sensor is 5 mm. Okay, so and then we label S2. Okay, so and then we can begin with 96 and then end it with 100. Okay, so what is meant by 0 to 5 and 96 to 100? Okay, so if you try to look at, that's actually 5 mm length. Okay, so from 0 to 5 and 96 to, okay, 100. So that means that the width of the what we call this one, the limit switch is 5 mm. Okay, so if we try to go back to, okay, so uh, the limit switch, so 0 means this part here. Okay, so it's situated at 0, and then the end part of the limit switch is 5. Okay, so if you try to look at, the limit switch must be situated at the farthest point wherein the cylinder can reach, and also a limit switch is situated in the nearest point wherein the cylinder can retract. Okay, so that's why we have there 0 to 5. That means uh, the cylinder or the limit switch is situated at the nearest point, the starting point of the cylinder, and then 5 means that's the width of the cylinder. Okay, and then uh, for the 96 to 100, so that means that the farthest point, this one, is situated at the 100 mm mark, because the cylinder can extend up to 100 mm, and then the width, so since the width is 5 mm, so it will start at 96 mm count. Okay, so that's how the ruler will work. So if you try to look at, so you have the sensor 1, S1, sensor 2, S2. So when cylinder is in retracted position, okay, so S1 detects the cylinder in retracted position. When cylinder extends, then S2 detects the cylinder in extended position also. So the positioning using the uh, distance rule will actually depend on the uh, length of the stroke that the cylinder can carry. So for example, the stroke is up to 50, then let's say, okay, let's say for example that you mistakenly write here, example, uh, 196, and then you end up with 200, for example. So the software will prompt you that the range of the cylinder is up to 100 mm only. Okay, so that means that the position of the sensor 2 is way too far from the maximum distance that the cylinder can reach. Okay, so that is why we'll have 96 to 100. So by the way, the width of the cylinder, I mean the width of the sensor, is dictated by you. So you may have 0 to 3, and then you may have 97 to 100. So the most important part in distance rule is that the beginning must be 0, and then the end part of S2, or the extended position sensor, must be the full length that the piston rod can reach. Okay, so that would be for sensor 1 and sensor 2. Okay, so in this example, okay, so in this example, we'll be using the application of a pneumatic jackhammer. So when you say jackhammer, so we'll try to create a control circuit wherein this cylinder, so will automatically extend and retract and extend and retract, so until it is being uh, turned off. Okay, so we'll try to make use of the concept of um, proximity switches. Okay, so to create a pneumatic jackhammer. Okay, so we'll be using the um, NEMA configuration, and then we'll try also to use the IEC configuration for your reference. So by the way, uh, proximity switches. Okay, so the limit switch or the reed switch are normally open switches. That means initially they are open. Okay, so uh, once they detect the presence of the position of a pneumatic cylinder, then that would be the time it will close. For example, sensor 1 is open, but since it detects that the pneumatic cylinder is in fully retracted position, thereby it closes. So sensor 2 is also open. So when the cylinder reaches the fully extended position, so sensor 2 detects that the uh, cylinder is in extended position, thereby sensor 2 closes its contact. But initially, so these sensors are normally open. Okay, so let's try to create the what we so called jackhammer. Okay, setup of pneumatic cylinder. Okay, so we begin with the okay. We'll use the NEMA configuration. Okay, so for NEMA, first we need to have the positive terminal and then the negative terminal. Okay, so then uh, we have the push button. Okay, so we have the push button, normally open push button. Okay, so we can have it here, and then that will be start. Let's have it start. Okay, and then the okay, you can adjust it here, and then the solenoid. Okay, so okay, so take note. So this should be Y1. Okay, then it will be connected to the negative terminal. Okay, so you can adjust it. Okay, so and then uh, okay, so we connect the start push button to Y1, and then we connect it to the positive terminal. So we can start by simulating first. Okay, so if we can run the okay, so the cylinder. So if you notice, okay, so we can adjust the speed. Okay, so we can make it 40% for example, and then this one is also 40%. Okay, so we can simulate it again. Okay, so in the jackhammer process, so the cylinder must extend and then retract and then extend and retract. Okay, so okay, so now the cylinder is in extended position. So the next step is to make the cylinder retract automatically. Okay, so now automatically means that the sensor, once it detects that the cylinder is in fully extended position, so it will give a signal. Okay, so it gives a signal for the control circuit to automatically retract the double acting cylinder. And since we're using 5 two-way double solenoid valve, so the only way to make this cylinder retract to its original position is to energize Y2. Okay, so but before Y2 will be energized, the system must be able to detect first that the cylinder is in fully extended position. Question: who will detect that the cylinder is in its fully extended position? So the answer is S2. So S2, once the cylinder is in extended position, it is now S2 that will detect. Okay, so we can make use of, okay, so we can stop the simulation first. So we can click this one, uh, make switch. Okay, so and then this would be limit switch, and then this will be labeled S2. Since we're using limit switch, so this will be labeled as S2. And you notice that the symbol for S2 changes. Okay, so a symbol for limit switch. Okay, so I'll try to zoom in. Okay, so this one. So try to observe what will happen to S2. Okay, so if we try to simulate, S2 is initially open, right? Okay, so again, sensors are normally open, or basically sensors are initially open. So, but when it detects position of the cylinder, it becomes closed. Try to look at S2. So if we try to run, so the cylinder creates mechanical contact with S2, thereby S2 now closes. Okay, so on the other hand, if we try to create an open contact and name this one S1, okay, so S1. So automatically S1 closes even though we choose to have an open contact. Why it closes? Because it detects that the cylinder is in retracted position. Okay, so try to look at this one. When we try to simulate, try to take a look at S1. When cylinder leaves, no, so when it leaves at this position, so it will make S1 open. Okay, so try to take a look. So S2 now becomes closed, S1 now becomes open. So why S1 becomes open? Because again, it is initially open. It just closes because it detects the presence of uh, the cylinder in retracted position. Okay, so okay, so we'll try to utilize. Okay, so let me zoom in. Okay, so now again, the objective is to create a pneumatic jackhammer. Okay, so when the cylinder extends, so the setup must be able to retract the cylinder. Okay, so this must be able to automatically retract the cylinder to its um, initial position. So how do we do that? So we make use of S2 to command the retraction process. Okay, so again, the only way that the cylinder can retract is to energize Y2. So we need to have Y2. Okay, so example, this would be Y2. Okay, so meaning to say, once the cylinder is in fully extended position, S2 will command Y2 to activate. So once Y2 will be activated, then it will retract. Okay. So again, sensors will be connected in series, and then everything will be connected in parallel, for example. Okay, so try to take a look at this example. Okay, so we try to simulate again. So we first, okay, so we can make it 5%. Okay, so 5% also. Okay, so try to look at, if we click start, okay, so the cylinder moves and then it automatically retract. Okay, so try to look at the process. So once we click this one, it activates Y1, thereby allowing the cylinder to extend. But when the cylinder is in fully extended position, S2 detects, and S2 automatically energized Y2, then the cylinder automatically retract. Okay, so we're not yet finished. So we're actually simulating the step-by-step process. Okay, so once S2 detects, Y2 now is activated, thereby allowing the cylinder to retract. Okay, so after this process, okay, so try to take a look at this one. After this process, since we want to have a pneumatic jackhammer, then uh, we must find a way that after the cylinder has been retracted, it will continue to extend again. Okay, so how do we extend the cylinder? So again, to extend the cylinder, then the solenoid coil Y1 must be activated. So this time, in the second extension, the activation of Y1 must be made automatic. That means without the use of the push button. At first, we click the start push button for the cylinder to extend, and then once it automatically retract. Okay, so the system or the control circuit must be able to extend the cylinder again without the aid of the push button. Okay, so we find a way wherein once the cylinder detects that the uh, double acting cylinder already retracted, so we find a way wherein the sensor will work, and then it will automatically extend the cylinder, and then repeat the same process, retract and then extend, automatically retract and extend, and so on until the operation is being stopped by the operator. Okay, so how do we know that the double acting cylinder is already in retracted position? So the only sensor that can detect that the cylinder is in retracted position is the limit switch S1. So we try to make use of S1. Okay, so wherein after the cylinder extends, when the cylinder retracts, S1 will be able to let the cylinder extend again, and so on. Okay, so to take note, the function of S2 here is to let the cylinder retract. So the function of S1 is to let the cylinder extend again. Okay, So meaning to say, we find a way wherein we can uh, activate Y1 automatically. Okay, so without pressing the start push button. So we can make use of the concept of latching contact. Okay, so in the latching contact, so which is provided by a relay, so we can have a relay to be connected in parallel with the um, solenoid coil Y1. Okay, so if we connect this one, so the function of this relay is to create a seal. So wherein even if uh, start push button is being released. Okay, so this creates permanent contact. Okay, so permanent contact for the relay to always energize the solenoid Y1. Okay, so we then click make switch. Okay, so this will be limit switch. Okay, and then label this one K1, and then, well, of course, this must be labeled K1 also. Okay, so you have there, okay, so K1. So, although uh, the 5-2-way double solenoid valve does not need a sealing contact for the cylinder to extend, but we use the concept of sealing contact. Okay, so in order for the cylinder to automatically allow itself to extend again. Okay, so let's try to take a look at the simulation. So when we press start, so Y1 activates, and then uh, okay, so Y2. Okay, so you notice that uh, when Y2, or when the cylinder activates, S2 closes and then it energizes Y2. However, okay, so take note, however, the cylinder does not retract. Okay, so why? Because Y1, okay, so take note, Y1, so the other coil is still activated. Okay, so this is the example I've given to you a while ago, that you cannot activate the two coils simultaneously, because once you activate the two coils, the cylinder will remain uh, struck. Okay, so it will remain in its position. It will be stuck in the position wherein or the prior position before you activate the two solenoid coil. So in this case, since the cylinder has extended, so when we activate the two coils, so it will remain in extended position. So okay, so uh, how do we use S1 to allow the cylinder to act as a pneumatic jackhammer? So take a look at S1 now. So when the cylinder is in extended position, S1 is actually open and S2 is closed. So try to observe what happens to S1 and S2. So when we start with the circuit, okay, so by stopping the simulation, So we now have the cylinder in retracted position. That means S1 is closed and S2 is open. Okay, so but when the cylinder is in extended position, okay, so S1 is open and S2 is closed. So again, the concept of a sensor is that when it detects the end of the piston rod, it changes contact. Okay, so a question is, does S1 detect the end of the piston rod? So the answer is no. So why? Because the cylinder is in extended position. So thereby, there is no contact between the end of the piston rod and S1. So that is why S1 is open. How about S2? Does S2 make a contact with the end of the cylinder? So the answer is yes. So why? Because the cylinder is in extended position. So thereby it creates contact with the sensor S2. That is why it becomes closed. So if we try to look at the starting point, does S1 create a contact with the cylinder? So the answer is yes. So why? Because the cylinder is in retracted position. So that is why S1 is closed. So for S2, question, does S2 make a contact with the cylinder? So the answer is no. So why? Because the cylinder is in retracted position. Okay, so then therefore S2 is open. Okay, so going back to the scenario, okay, so once the cylinder extends, so it makes Y1 and Y2 to be energized at the same time. So thereby making the cylinder to be uh, in extended position. Nothing happens after. Okay, so now you notice, try to take a look at S1. So you notice that when the cylinder is in extended position, S1 becomes open. So meaning to say we can make use of sensor S1 to uh, turn off one of the solenoid coils. So in order for the uh, cylinder to retract. Okay, so now whose solenoid coil will be turned off by S1? So the answer is Y1. Okay, so we need to turn off Y1 because we need to retract the cylinder to its initial position. Okay, so how do we insert Y S1? So we insert S1 by connecting S1 in series with Y1. So if you try to look at first, okay, so we connect S1 in series with Y1, and then we will understand what is the importance of the latching contact in this example. Okay, we try to simulate. So before this one, we'll try to even have a smaller opening, 3% for example. Okay, so we try to start. So you notice that S1, okay, okay, so try to observe first the extension of the cylinder. So if you try to look at the circuit, okay, so S1 is closed, S2 is open. So when we click start, it activates Y1 together with K1. Okay, so it activates Y1 together with K1. So K1 provides seal. That means even if the uh, start push button is uh, released, so this allows the circuit in this part here to be always activated. Okay, so again, try to take a look at what happens to K1. So you focus your attention first in this control circuit. Okay, so when we press, so K1 is activated, so it creates a seal. Okay, so when the cylinder is in retracted position, when it extends, so S1 opens, thereby de-energizing Y1. Okay, so once it is in fully extended position, it closes S2, thereby activating Y2. So thereby retracting the cylinder in the process. So once the cylinder is in fully retracted position, okay, so like this one, so it closes S1, and then since K1 is always activated once S1 is closed, okay, so when we close S1, so that makes Y1 to be activated as well. Okay, so even without pressing the start push button. So S1 is being actually used as a switch for Y1 to be energized and energized. So thereby we have now the uh, pneumatic jackhammer. Okay, so it automatically extend and retract. Okay, until the operator make a stop in the operation. So how do we stop the operation? So we need to insert, circuit a stop button. Okay, so we cut off the supply first. Okay, so and then we insert. Okay, so close push button. Okay, and then that would be stop push button. So meaning to say, if we try to press this one, so the supply, the entire circuit will be uh, de-energized. Okay, so like this one. Okay, so you can stop the process. Okay, so okay, we stop it. Okay, okay, or start. So the process would stop. Okay, so just like, okay, so we can, okay, so increase the speed 40%, 40%. Okay, so that would be, and then you can stop anytime. Okay, so again, we can, when you press stop, okay, so that would be the function of a stop push button. So with this, you are now ready to perform experiments 1 to, okay, experiments 1 to 6. Okay, so you can also try to construct, by the way, the control circuit using the IEC format. Okay, so for the IEC format, by the way, so push button comes into two types. So you have there the spring return push button, and then the detent switch. So the detent switch actually is a non-spring return push button. Okay, so for example, this one. So when we simulate, so when you press, so this push button will remain closed unless otherwise it is pressed again. Okay, so when it is pressed again, it becomes open. So when you press that, it becomes closed, and then you press again. So again, the difference between the push button and the detent switch is that push button is spring return type, detent switch are non-spring return type, meaning to say you need to press it again to become open. Or when you use normally close, for example, okay, so you simulate, you press that one, that will remain open. You need to press it again to make it close again. Okay, so that is actually the difference between the detent switch and the push button. So the detent switch actually is very useful when you have the AND operation. So that means when you will be simulating two push buttons uh, at the same time. So what I mean by simulating two push buttons is that when you are simulating a system wherein you need to click two push buttons at the same time. So in the computer, you cannot have two cursor of the mouse at the same time. So one must be detent switch and then the other must be spring return. Okay, so this will be emailed to you. Okay, so such that you can perform experiments 1 to 6. So additional instructions will be given in your Moodle account.